Hey everyone, we're going to talk about VoIP. VoIP stands for Voice over Internet Protocol. It is a technology that allows phone calls to travel over internet networks instead of traditional telephone lines. VoIP converts your voice into digital data packets, then sends those packets across a network. Then the receiving device reassembles the packets, so the audio is reconstructed on the other side in near real time. Traditional phone systems use circuit switching, which means you made a call, the phone company created a dedicated connection between both callers for the entire duration of the call. VoIP uses packet switching, which is the same general concept the internet uses for websites, streaming, and email. The IP in VoIP stands for Internet Protocol. Internet Protocol is the addressing and routing system that devices use to communicate over networks. Every device connected to a network has an IP address. VoIP systems use these addresses to route calls between devices and providers. VoIP traffic can travel across the public internet through private corporate networks, over VPNs, through MPLS networks, and across wireless networks like Wi-Fi and LTE/5G. Codecs are extremely important in VoIP. A codec is responsible for converting analog audio into digital form, compressing the audio, and decompressing it on the receiving side. Different codecs balance the audio quality, bandwidth usage, latency, and CPU usage. I'm not going to go super deep in this video, but just know the VoIP process gets very technical. I'm just going to go over some of the basics. Anyways, a soft phone is software that functions like a phone. Some examples are desktop apps, mobile apps, and browser-based calling systems. Soft phones can register to SIP servers, make calls, receive calls, and use headsets or microphones. This is why many businesses can run phone systems entirely from laptops now. A hosted VoIP means the provider hosts the phone system in the cloud. There are advantages and disadvantages to this. Some advantages are easier deployment, less hardware, lower maintenance, and they are remote friendly. Some disadvantages are less control, monthly recurring costs, and dependence on provider uptime. The on premises VoIP means the organization hosts the PBX internally. PBX stands for Private Branch Exchange. Traditional PBXs used physical phone lines. Modern IP PBXs use VoIP technologies instead. Some common IP PBX platforms include Asterisk, Free PBX, Cisco Unified Communications Manager, and 3CX. Advantages for on premises VoIP include more control, customization, and internal management. Disadvantages include more maintenance, requires infrastructure, and requires expertise. Now let's talk about the quality of service. VoIP is highly sensitive to network conditions, unlike email or file downloads. Voice communication happens in real time. Problems can occur if packets arrive late, out of order, or dropped entirely. Quality of service helps prioritize voice traffic on networks. Quality of service mechanisms can prioritize RTP packets, reduce delay, prevent jitter, and improve call quality. Some important VoIP performance terms to know: latency is the delay between speaking and hearing. Jitter is variation in packet arrival timing. which is too much jitter causes choppy audio, robotic voices, and audio gaps. VoIPs VoIP devices often use jitter buffers to smooth this out. Packet loss is when some packets never arrive. Small packet loss may sound minor, but higher packet loss can cause missing words, distorted calls, and broken audio. VoIP often struggles with NAT. NAT stands for Network Address Translation. Routers commonly hide private internal IP addresses behind one public IP. This creates issues because SIP and RTP were not originally designed with NAT in mind. We didn't get into SIP and RTP in this video. SBCs, or Session Border Controllers, are extremely important in enterprise VoIP. We are not getting into that in this video either. But they can be thought of as a security and control layer for VoIP infrastructure. VoIP introduces multiple security concerns. Some of the risks include eavesdropping, which is attackers capturing voice packets, SIP registration hijacking, attackers impersonating devices, toll fraud, attackers abuse phone systems to place expensive international calls, and DDoS attacks, which is when attackers overwhelm VoIP infrastructure with traffic. Two major encryption technologies that are common for VoIP are TLS and SRTP. TLS encrypts SIP signaling, which protects credentials and call setup data, and STRP encrypts the voice media itself. It protects the actual audio conversations. VoIP systems still often connect to the PSTN, which stands for Public Switched Telephone Network. This allows calls to normal phone numbers and communication with traditional phones. Gateways or SIP trunk providers usually handle this connection. VoIP became popular for several major reasons, including for cost savings, especially for long distance calls, international calls, and infrastructure consolidation. There is more flexibility. Users can work remotely on mobile devices and across multiple locations. Scalability. Adding extensions often becomes mostly software configuration. VoIP systems commonly include voicemail to email, call recording, auto attendance, presence, uh, video calling, and CRM integration. Modern VoIP is often part of unified communications platforms. This can combine voice, video, messaging, collaboration, screen sharing, and presence information. Platforms like Microsoft Teams, Zoom Phone, WebEx calling integrate these services together. Modern cellular systems also use VoIP technologies internally. LTE networks commonly use IMS and VoLTE, which stands for Voice over LTE. So even many mobile calls today are technically IP based phone calls. VoIP creates unique challenges for emergency calling. Traditional landlines were tied to physical locations. VoIP users can move anywhere, which complicates 911 location tracking and emergency routing. Modern systems use E911, location databases, and dynamic location services. Faxing can be unreliable over VoIP because fax protocols were designed for analog lines. T.38 is commonly used to improve fax reliability over IP networks. The line between VoIP calls and cell phone calls is blurry nowadays. Modern cellular networks actually use a lot of IP based technology internally now. At a high level, a traditional cellular call uses the mobile carrier's cellular voice infrastructure. A VoIP call uses internet based networking to carry voice traffic. Older cellular systems used circuit switch networks, which means a dedicated voice path was established. The carrier controlled the entire connection, and voice traffic traveled through telecom switching infrastructure. This was common in 2G and early 3G networks. Voice and data were often separated. Phone call network and internet/data network were two different systems. Modern cellular networks are different. Today, many cellular calls use VoLTE, VoIP, voice over LTE, and VoNR, voice over new radio on 5G. These are actually forms of VoIP internally. Your phone converts voice into IP packets and sends them over the carrier's LTE or 5G data infrastructure. But there's a major distinction. The carrier tightly manages the network. Quality is prioritized, and specialized telecom infrastructure handles routing and control. The technology underneath resembles VoIP, but it is still carrier controlled telecommunications. So, to simplify the difference between cellular calling and VoIP calling, cellular calling, your phone connects to a nearby cell tower. The carrier authenticates your SIM. Voice traffic enters the carrier network. Call routing occurs through telecom infrastructure. Then audio reaches the other party. For VoIP calling, app or IP phone registers to a server. SIP signaling establishes the call. RTP streams carry audio. Internet routing handles packet delivery, and audio is reconstructed on the receiving side. Wi-Fi calling is kind of a hybrid. With Wi-Fi calling, your carrier voice service travels over Wi-Fi internet, but the carrier still controls the call infrastructure. So, it behaves like a cellular call, but technically uses IP transport. Why cellular networks move toward VoIP, you may ask? Packet switch networks are more efficient, more scalable, easier to integrate, and better for multimedia, instead of separate systems for voice, text, and data. Modern networks unify everything into IP infrastructure. A lot of communication systems are converging. Today, cellular uses IP, business phones use IP, messaging apps use IP, and video calls use IP. The distinction is becoming less about the underlying transport and more about who controls the infrastructure, how the service is managed, what protocols and platforms are used, and what reliability and quality of service guarantees exist. Anyways, I hope that I have explained this well enough for you. My bad if I was confusing. VoIP can get much more technical. There are many things I did not get into. I appreciate you watching, and remember, Floppy Tech loves you.